So shifting gears a bit, let's try to find an equation of a plane in R3. So let's say this is my plane in R3. Okay. And let's say there is a vector n which is given by ABC, and this vector is normal or perpendicular to the plane. All right, so this n vector is normal normal to this plane. And let's say there is a point P naught that lies on the plane. Then any arbitrary point P, which is given by its coordinates x, y, z, will lie on the plane if the vector from P naught to P, right, is perpendicular to n. So basically it means that the vector P naught P has to be perpendicular to n. So, and we know that if two vectors are perpendicular to each other, their dot products would be 0. So let's exploit this result. So the vector P naught P would be given by x minus x naught, y minus y naught, z minus z naught, and we'll dot it with the vector n, which is a, b, c, and their dot product would be 0. So, and now we have done this many times earlier too. So this can be expanded like so: ax minus x naught plus by minus y naught plus cz minus z naught is equal to 0. And this implies that ax plus by plus cz is equal to ax naught plus by naught plus cz naught. And the RHS of this equation, right, is a constant. So all these terms are constants here. So we can replace the RHS with a single constant called d. All right. And thus the plane has an equation of the form ax plus by plus cz is equal to d. All right. So for example, the plane x plus 2y minus z is equal to 0. So this is an example. This is a plane that passes through the origin, right? Because you can plug in these values for x, y, z, and you will see that this satisfies the equation. And the normal vector for this plane will be 1, 2 and minus 1. All right. So let's take another example. So let's try to find the equation of a plane in R3 that has 1, 2, 3 as its normal vector, and it passes through a point 1, 1, 1. Okay. So we know that the plane with normal vector 1, 2, 3 will be of the form x plus 2y plus 3z is equal to d. And we also know that it passes through 1, 1, 1. So plugging in the x, y, z values for the plane, we get 1 plus 2 plus 3 is equal to d, which implies d is equal to 6. So the equation of the plane is x plus 2y plus 3z is equal to 6.